Lewis structures, molecules and polyatomic ions with double and triple bonds. What is a double bond? A double bond is when atoms share two pairs of electrons. Usually in a single bond, in a covalent bond, the sharing of electrons happens between one pair of electrons. We call that when we have one pair of electrons being shared, we call that a single bond, and it has a certain length. And so that the length between a single and a single bond is the distance between the average distance between the two nuclei of the atoms involved in the bond. But as the number of shared electrons increases, so in this case 2 pairs of electrons, the atoms are pulled closer together, leading to a decrease in the bond length. So the bond length is shorter than a single bond for a double bond. So it is shorter than the single bond. So remember that that's the average distance. So in a triple bond, we can assume that atoms share 3 pairs of electrons. So triple means 3, double 2. So triple means they share 3 pairs of electrons, and the bond length is then shorter than a double bond. And so here's an example of a double bonded Lewis structure. So CO2 has a double bonded Lewis structure. So if I draw it out, the Lewis structure, actually I'm going to draw the O here, and I'm going to draw its Lewis dots like this, so I can better show how the electrons are coming together. So C has 4 valence electrons, so I'm going to draw 2 here and 2 on this side, and oxygen 2 here, and oxygen has 6 valence electrons. So to get 8 valence electrons for oxygen, actually it starts to share this one, and it shares this one, and it shares this pair, and it shares this pair. So it has a double bond here and a double bond on this side. So it has 2 double bonds. Notice if I count this line, remember it counts for 2 valence electrons. So I have 1, 2, 3, 4, 5, 6, 7, 8. So oxygen is happy. Carbon is happy because 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So oxygen is also happy. So this is an example of a double bond. And remember that that bond length is shorter than it would be if there were single bonds in it. Now, for a triple bond, we can take, for example, acetylene. So I can put it like this. It's actually C2H2. So if I draw the Lewis dots structure, it's going to have 3 valence electrons. So actually I'm going to draw it like this: 1, 2, 1, 2, 3. So that's 4 valence electrons. 1, 2, 3. This is 4. So this is the valence electrons of this carbon, and this is the valence electrons of this carbon. And remember, hydrogen has 1. This hydrogen has 1. And notice, this bond is forming a single bond here, and this bond is forming a single bond. But notice these C's are going to form a triple bond, sharing these 3 pairs of electrons. And so this is the Lewis dot structure for acetylene. It has 3 bonds, 3 pairs of electrons sharing. So the bond length is even shorter than it was in carbon dioxide that we had drawn up here. So remember that double bonds is a sharing of 2 pairs of electrons. Triple bonds are sharing of 3 pairs of electrons, and you get shorter the more bonds that you have, the more the shared electrons you have.